Okay, folks, so this is the setup lab for the lab 4. You should, in theory, be able to try to do it with the manual, but this video can be watched to get you set up. So we're looking at second order differential equations, which have to be converted into two first orders. Okay, so we're going to, in worksheet 1, we're going to solve a specific problem. This is in Excel, not in VBA, so there's no dashboard or anything like that. So by hand write this as a system of two first orders. I won't do this here, this will be covered in lectures. And I'll hopefully be able to kind of do it in my own head. So label time in column A. I'm going to go from 0 to 5 in steps of 0.1. I'll let you finish that. X in column B, X is displacement. Here, 1 is the initial displacement. We should be able to see this from the differential equation. Yeah, x of 0 is 1 and x dashed of 0 is 0. Now we let x dashed or dx dt be v, and we work as so. You can do your kind of nice stuff here. Right, so that's the setup. What's point 4? We want to write the code to do an Euler method here and an Euler method here. So Euler method is equal to previous plus step size times the slope of x. So that'll be dx dt, to figure out what that is. And then for v, it's equal to previous v plus step size times previous slope. So the question is what slope of v dv dt, you'll have to have that figured out. You drag these down and you should get something like that. So that's your setup. Right, into VBA, so let's set up a new sheet here. So this is one where we'll have a dashboard and stuff like that. We're going to have TXV again, and a button, maybe here, and then a dashboard. So in particular, we can see that we're going to need initial X, we're going to need initial V. We know we're doing some kind of numerical methods. We're going to have a step size, we're going to have a final time, and well, what else are we going to have? We'll see. Remember our framework for VBA is, well, let's see it on the, let's pause the video a second. Hopefully this is a bit better, but it's in your manual there. What is the framework? So option explicit, good for various reasons. So we're going to define variables. We're going to give them initial values, and then our big loop. And what's our loop going to do? Well, it's inside a do stuff loop, maybe until some condition. And what is the stuff? So the stuff we want to do is print current TXV, and then calculate next TXV. So I guess that's the basic framework. So let's go back into our thing. Yeah, so that's the basic thing. So this is what we're working with. So we're going to see more variables that we need. So step size, final time. We've got damping coefficient, that's our lambda there. Mass, spring constant, everything else is good. Maybe make that a bit smaller for ourselves, just for our screen here. Yeah, so it's the usual crack. What we see, we want to populate this, maybe 1, 0, step size 0.1, 5 times 10, lambda. Actually, I want to maybe match the previous one. So I think the previous one had a lambda of 5, mass of 2, spring constant of 6, step size of 0.1, I think it was, in the final time 5. So we can just match up with our Excel when we get there. Okay. So we want to give everything an initial value. We're just doing Euler's method. Really, we should be pushing it to Heinz method, but we're just going to leave it as Euler's method here with the understanding we can go a bit better. Yeah, so possible outline, we're going to use column A for the times. We can see that column B for the displacements and column C for the velocities. Wipe the previous output using the macro recorder. So we'll see that in the next video if you don't know how to do that. Set up the dashboard, initial time is 0. Yeah, dashboard, blah, 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 write a loop. So the loop should do these things. There's a warning that I'll let you work with initially. So, am I doing this work? Yeah. So I've got all the variables. So that's like my dim, etc. So I may as well put them in here. So we're going to have x, v, t. They're the most important. And h, final time, lambda. I'm just going to do lam, m, k, and I need a row counter as well. Give them their initial values. So the stuff. So yeah, it's pretty much there. The only thing that's missing, I guess, is the R. And everything else is kind of similar to before. So this is your basic setup to give it a bash. And then we've got these parameters we've seen before. So then you can play with it after that. So we'll let that finish. And now to push it to Heinz method. Now what we're going to do now is we're going to kind of develop this code. So it's going to be pretty much similar. So I'm going to actually, if I can, copy this setup, move to the end. Yeah, so this is, say, Hein. So I'm going to keep a lot of the structure the same. I will probably need a new button. So I'll delete that and insert a new button. The old button is referring to old stuff. Yeah, go on. And the only thing that's different here, oh, this is handy. I just want to check command button 1 and command button 1. So the copy and paste seems to have worked okay, which was a little bit dodgy. I would have preferred to have copied and pasted the code myself, but it looks okay. Yeah, no, it seems to work. So the only additional things, because we're doing Heinz method, we need an X predictor and we need a V predictor. So there are the additional things we need here for Hein. And yeah, so okay, give it a go. And then additional things you could do is include external forces. Now we'll try and set you up for the exercises, the 2 exercises. So now it's saying Hein method, okay. I think when it comes to the assessment on this, I'm going to be happy with Euler, by the way, but we may as well push it. So this one is van der Pol. Rename van der Pol, and then also the real pendulum. Okay, so van der Pol. Now the equation is back there. It's a displacement, time, displacement, velocity. Okay, and the user input is initial x, the initial velocity, the mu, step size, and the final time. They're all the things in your dashboard. And I guess we're going to probably we can copy a lot of what we had already. So I'm going to go, I'm actually going to copy and paste because it's also called command button 1. We're doing Heinz method, so we should go to the other one with the predictors. Yeah, so it's going to be pretty much the same as this. And that's that set up. And then the last one, so this one is slightly different. So you're going to have time, and rather than displacement, you have angular displacement, which is theta, and then angular velocity is omega. And then what we want, initial angle, initial angular velocity, length of the pendulum, step size, final time. And I think everything else is going to be quite similar. So I'm going to insert the button, and I'm going to actually copy and paste the code again. I've told you not to do, but like this is only a framework. So this is theta predictor, omega predictor. Now the stuff I said about lambda I'll have to go back on. So the only thing here we have is the length of the pendulum. So if we go back to our we'll just go back to van der Pol. Yeah, so we do not have lambda mk, we just have mu. Okay, so that's the basic setup, I think. And so give it a bash from there and see how you get on.